Hello there, Mr. Sutton here, bringing you this IM3 1.4 Extra Practice number 3 solutions on solving systems of equations involving word problems. This one is a puzzle, so let's check out that puzzle. Here's the original worksheet, and they're asking, how did the doe win the big animal race? To solve this riddle, we have to solve all of these systems problems below. These will eventually be systems of equations once you convert the word problems into a system of equations. Once you solve each of these, we have to cross out the box down below here that contains the answer, and then the letters that are left over will spell the answer to this riddle. All right, let's do this. For the opening problem, Mr. Merrill has 3 times as many nickels as dimes, and the coins have a total value of $1.50. So how many of each coin does he have? So we're going to start by getting some variables. We'll let n be the number of nickels, because that's one of the things we're solving for. And d will be the number of dimes. So now we have to set up 2 equations involving these variables. So the first sentence here, 3 times as many nickels as dimes. That means that the number of nickels, n, is going to be 3 times the number of dimes, 3d. So we can then write n equals 3 times d. Now for my other equation, we're talking about the value of the coins. So we need to do something with the n and the d that all adds up to 150. And I think I'll make this in terms of cents rather than dollars, just so I don't have to mess around with decimals. So if I take the value of all the nickels and add to that the value of all the dimes, we should get 150 cents. How can I represent the value of all the nickels? Well, each nickel is 5 cents. So 5n, 5 times n, would give me the money from all the nickels. And now the value of all the dimes, that's going to be 10, the value of a dime, times the number of dime times d. So that would be plus 10d. And again, that should all add up to 150 cents. Again, note that I did all of this in terms of cents rather than dollars, so no decimals. All right, at this point, we are ready to solve this equation, system of equations. Now, we could use substitution or elimination, but since I already have n isolated over here in my first equation, this is basically set up for substitution. So I'm just going to take this 3d and swap it in for the n over in this other equation. So now I can write 5 times 3d plus 10d equals 150. And now I have everything in terms of d, so I can just solve for that one variable. So this is going to be 5 times 3d is 15d. 15d plus 10d is going to be 25d. And now to get d by itself, I can just divide everything here by 25. 150 divided by 25, that's asking how many quarters do I have basically in a $1.50, and that's going to be 6. So there are 6 dimes that we have here. Now to find the number of nickels, because we needed to know that as well, we're going to plug 6 back in for d in one of these starting equations. I think this first equation is a good one because there's lots of room here and n is already by itself. So if I plug in 6 for that d, 3 times 6 is going to give me 18 nickels. So I have an 18, 6 or a 6, 18. I'm looking for either one up here in these boxes. And I see 18, 6 right here. So let's go with the ON. We're going to cross off that box and move on to the next question. On this one, we're told Ms. Lynch has 21 coins in nickels and dimes with a total value of $1.65. How many of each coin does she have? Okay, so let's go ahead and come up with some variables first off to represent these different things. So we've got, let's see here, nickels and dimes. Let's let n be our nickels, number of nickels, and d is the number of dimes. We're told we have 21 coins between the two of them. So that means the number of nickels plus the number of dimes, n plus d, has to add up to 21. We also have this equation about the total value being $1.65. So the value of the nickels plus the value of the dimes has to be 165 cents. To make my life easier, I'm going to put all of this in terms of cents so I don't have to worry about decimals. So the value of all the nickels, that's going to be 5 times n, because each nickel is worth 5 cents, plus the value of all the dimes, that's going to be 10 times d, equals 165 cents. So there is our second equation. Now to solve this, I could use elimination or substitution. I'm just going to go with elimination here. So I'm just going to multiply this first equation by something that's going to cancel out one of the variables over here. So let me think here. I just need to pick a direction and go with it. So let me cancel out the n's. If I make this over here a negative 5n, that would cancel the 5n in the second equation. So if I multiply this first equation by negative 5, then I can write it down here. So I've got negative 5n minus 5d equals 21 times negative 5 is negative 105. Now I can add these equations together. That cancels out my 5n's. 10n plus negative 10d plus negative 5d is going to be 5d. And now 165 plus negative 105, that's going to be 60. Dividing both sides by 5, I end up with d equals 12. So 12 dimes. Now I just have to plug that back into one of the equations. I'm thinking this one over here, the first equation is a good candidate. If I plug 12 in for d over there, I can now write n plus 12 equals 21. And then just quickly subtract 12 here to solve for n. That's going to be 21 minus 12 is 9. So 9 nickels. Looking at my boxes up above, I'm looking for a 9 and a 12. 9 and a 12. And I see that right here at the very end, so let me cross that double L off, and I'm ready to go here. For this problem, we have a vending machine that takes only dimes and quarters, containing 30 coins and a total value of $4.20. How many of each coin are there? So let's set up our variables. D will be the number of dimes, Q the number of quarters. And since there's 30 coins and we know that there's only dimes and quarters, that means if I take the number of dimes, D, and add to that the number of quarters, Q, that total should come out to 30. So we can say D plus Q equals 30. So there's one equation. It's not going to be enough to solve, though. So I also need to figure out an equation talking about the value of the coins, this $4.20. So if I take the value of all the dimes, which I'll call 10 times D, because each dime is 10 cents, and I add to that the value of the quarters, so plus 25 Q, that should add up to $4.25. But now since I've expressed this in terms of cents, 10 cents, 25 cents, I'm going to express my 420 as 420 cents, so no decimal. That way, since we're keeping units consistent, that means this equation will actually make some kind of sense once I solve it. Now, in order to solve this system, I need either substitution or elimination. Since I've got two easy variables here to isolate, I could use substitution. I'm going with elimination anyway because it's just as easy to multiply this equation by either negative 10 or negative 25 to cancel out one of the variables over here. So I'm going to cancel out the d's. To do that, I'm going to make this d over here a negative 10d, and I'll have to multiply that whole equation by negative 10. So that's negative 10d, which will cancel the 10d in a minute, negative 10q, and then 30 times negative 10 is negative 300. Adding these together, the d's cancel. I've got 25 plus negative 10 is 15q. 420 minus 300, that's going to be 120. And if I divide both sides by 15, I happen to know that that's going to be 8. 8 times 10 is 80. 8 times 5 is 40. 80 plus 40 gives us the 120. So 8 quarters. Now I just need to plug that back in. Over here seems like a good spot. We've got D plus 8 quarters equals 30. If I subtract the 8 quarters from 30 coins, that leaves me with 22 coins that are dimes. So I need to now find an answer box that has a 22 and an 8 in it. They don't have any units, so I'm just looking for the numbers. Looking up here, that's actually this first box, it. Well, it is gone. For this one, we have the total value of the $1 and $5 bills in the cash box being $124. There's 8 more $5 bills than $1 bills. How many of each are there? Okay, so let's set up some variables. I'm going to let X represent the number of $1 bills, and then Y will be the number of $5 bills. And we'll come up with a couple of equations here. Now, they told us that the total value of all these bills was 124. So if I take the total value of just the $1 bills, I can write that as 1 times X, just however many there are, that's how much it's worth. And if I add to that the value of the $5 bills, so that would be 5 times the number of those, 5 times Y, that should all add up to 124. Next, they told us there are 8 more $5 bills than $1 bills. So that means the number of $5 bills, Y, should equal the number of $1 bills, X, plus 8, 8 more than X. And at this point, I need to solve this system of equations. Now, between my two go-to methods, elimination and substitution, since this Y is already isolated in the second equation, I'm going to go with substitution and just plug in the X plus 8 for the Y in the first equation. So I'll rewrite this first one as X plus 5 parentheses, X plus 8, equals 124. Next, let me go ahead and distribute this 5 to my parentheses. So I've got X, I've got plus 5X, and plus 40, 5 times 8. Combining like terms now, I've got 6X on the left side. And then let me go ahead and subtract 40 from 124 to get the 6X by itself. So that'll be 84 over there on the right. And then finally, dividing both sides by 6. Well, let me think here. 6 goes into 60 10 times. This is 24 more than that. So that's going to end up being 10 plus another 4 is 24. No, actually, is that right? No, it would be 14, right? 6 times 10 is 60 plus another 24. That would be 14. X equals 14. Or I could just be humble and use a calculator. But why would I do that? So let's plug 14 now back in for X up here. So that's going to be 14 plus 8 equaling Y. And then that means we have 22 of the $5 bills. So we have 22 and 14, or 14 and 22, either way. Let's see if we can find those two numbers in the answer boxes above. That's this one right here under the AN. So we'll cross that off and move on to the next question. So for this one, we have a collection of nickels and quarters amounting to $2.60. 16 coins altogether. How many of each coin do we have? So let me set up some variables. N is the number of nickels I'm going to say, and then we'll use Q for number of quarters. And between the two equations to set up, I'm thinking I'm going to start with this sentence about the 16 coins. That seems like a pretty easy idea. If I take the number of nickels, N, and add to that the number of quarters, Q, it should add up to this 16 that they're talking about. So that's one quick, ready-to-go equation. Now, my other equation, I'm going to use the value of the coins, this $2.60. If I take the value of all the nickels, 5 times N, because there's 5 cents in a nickel, and I add to that the value of all the quarters, so plus 25Q, that should add up to, well, let's see, these are both in terms of cents. So I'm going to write 260 instead of 2.6, just so I have it in terms of cents instead of dollars. And at this point, let me go ahead and solve this system of equations. I'm going to use the elimination method on this one, which means I'm going to try to add together the equations in a way that cancels out one of my variables. Nothing's going to cancel out right now. However, if I could turn this into a negative 5n or this q into a negative 25q, either of those would allow me to add the equations and cancel things. I'm going to go with making this a 5n just because I like multiplying by smaller numbers if I have a choice. So I'll multiply this first equation by negative 5. That gives me that negative 5n that I was looking for, but it also gives me a negative 5q, and 5 times 16 is going to be a negative 80 over on the other side of the equation. Now adding these together, we have the n's canceling out. 25q plus negative 5q is 20q, and then 260 plus negative 80, that's going to be 180. Dividing both sides by 20, we end up with Q equals, let me see, that's going to be 9 quarters. To find the number of nickels, I can plug this back into my first equation. So N plus 9 equals 16. Subtracting my 9 quarters from my 16 coins total gives me 7 nickels to end this one. So I need a 7 and a 9 together in one of these answer boxes up here, and it looks like that's the ER part of this. So cross that off and go on to the next one. For number 6, we have Joe Lick, who bought some 20-cent and 25-cent stamps, 32 stamps in all, and paid $7.40 for them. We want to know how many of each kind. So this is very similar to all the other problems we've been setting up. We're going to have an equation talking about how many stamps and another talking about the value. But first, let's get some variables. I didn't really have any good letters in mind for 20 cent versus 25 cent. Those are really too similar for my taste to begin with, but I'm going to call them X and Y. X will be the number of 20-cent stamps, and Y will be the number of 25-cent stamps. So we have an equation talking about how many of each there were compared to this 32 total. So I can write X plus Y, the number of 20s and number of 25-cent stamps, equals 32. We can also talk about the value of all the stamps. So if we take the value of all the 20-cent stamps, which in terms of cents ought to be 20 times X, and we add to that the value of all the 25-cent stamps, so that's going to be 25 times Y. Adding those up should give us our $7.40, which I'm going to write as 740, just so everything is in terms of cents and I don't have to mess around with decimals. So, am I using substitution or elimination for this? Well, I like to use elimination when I already have both things in standard form. So, if I could make this a negative 20x or a negative 25y, either of those is going to allow me to cancel out something in the other equation. So given a choice of things, I'm going to go with making this a negative 20x because multiplying by negative 20 is a little bit easier than multiplying by negative 25, I think. So that gives us negative 20x, which is what I was after, negative 20y, which just happens to be there, and then 20 times 32, that's going to be 640, and that's negative because we have a negative 20, so negative 640. Adding those equations together. The x's are canceling, that's delightful. 25y plus negative 20y, that's a 5y. And 740 plus negative 640, well, that's 100. That's not so bad, right? To get y by itself, dividing by 5, 100 divided by 5, well, that is 20. So this is kind of weird, but we have 20 of the 25-cent stamps. So again, very, very weird problem with these numbers so close together and getting an answer that goes with the other one. Anyway, plugging that back into this equation, I'm going to now try to find the number of 20-cent stamps. So I have x plus 20 equals 32. Subtracting 20, we have x equals 12. So that is 12 of the 20-cent stamps. So my numbers that I'm actually looking for are going to be 12 and 20, not 20 and 25, 12 and 20. Looking up here for those two numbers, I see 12 and 20 here under the KI, so cross that off, and we'll move on to what I believe is the final problem. All right, so I misspoke. This isn't the last problem, but it's the second to last. It's the last normal problem anyway. The last one is kind of a doozy. So we have a school play, 340 tickets valued at $810. Some of them are $2, some of them are $3. How many of each type? So let's start with some variables for the different types. For the $2 tickets, I'll use X, and then Y will be the number of $3 tickets. This first sentence has a lot of info packed in one place. So we can talk about the number of tickets overall that were sold, 340. If I take all the $2 tickets, X, and add to that the $3 tickets, Y, that should all add up to 340. So there is one of the two equations I need. Now this 810 value is also going to be important. If I take the value of the $2 tickets, 2 times X, and I add to that the value of the $3 tickets, 3 times the number of them, 3 times Y, that should all add up to 810. So at this point, it's time to solve my system, either with elimination or substitution. Either would work pretty well for this, but since they're already in standard form, I'm going to go with elimination. So to get these to cancel out one of my variables when I add the equations together, I'm going to multiply this first equation. So I'm going to try canceling out the x's. So I'll multiply this first equation by negative 2. That'll give me a negative 2x that I know is going to cancel this 2x. And then negative 2 times y, negative 2y. And then negative 2 times 340, negative 680. Adding these together, the x's are canceling. We've got 3y plus negative 2y is just y. And then 810 plus negative 680 is 130. So that's the number of $3 tickets. If I want the number of $2 tickets, I'm going to plug in 130 for y. This equation works as well as anything. We've got x plus 130 equals 340. And then subtracting that, we have x equals 210. So that's 210 of the $2 tickets. Looking for a box that has 210 and 130 in it, that's going to be this EN box right here. So draw a line through that, and we can move on to the real final problem. All right, here we go. Final boss battle. And they really picked one for you here. So Romeo, it always comes down to love, doesn't it? Bought a mixture of 20, 35, and 50-cent Valentines. Number of 20 cent was one more than twice the number of 35 cents, and the number of 50 cents Valentines was two less than the number of 35-cent ones. We'll go through all that again. It's just a big mess here. What we're asking is if he spent $4.20 altogether, how many Valentines of each type did he buy? So one thing to recognize right away is that there are no longer just two things we're trying to find, but three things, 20, 35, and 50-cent Valentine quantities. So we're going to need not two, but three variables to represent all this. I'm just going to use x, y, and z because what else am I going to use here? So x, that'll be the number of 20-cent Valentines. Y is the number of 35-cent ones. And z will be the number of 50-cent Valentines. So we really need to start using variables to keep all this information sorted out. Now let's go through and write some equations. The number of 25-cent Valentines, so that's going to be x equals, is one more than twice the number of 35-cent Valentines. So twice the number of 35-cent would be 2 times y, and we want one more than that, so we're going to have to add 1 there. So there's one equation, x equals 2y plus 1. Thankfully, only has two variables in it, not three. Next up, they said the number of 50-cent Valentines, so that was z, equals 2 less than the number of 35-cent ones. So the number of 35-cent ones was y, and we wanted 2 less, so minus 2. And then they give us one more equation here. He spent $4.20 altogether. So we can actually talk about the value of all these things being added together and adding up to 420 cents. So we've got the value of all the 20-cent Valentines, 20 times x. We're going to do this in cents here. Value of all the 35-cent ones, so 35y, and we're adding that. And finally, we're going to add the value of all the 50-cent Valentines in there, 50 times z. And that should all add up to, we're going to write this as 420, just so it's all in terms of the same units, cents, which makes more sense than dollars, just so I don't have to mess with decimals. All right, so this is three equations. We have to solve a system of three equations. Now, normally this would be pretty tricky, but they've actually helped us out a little bit. If you look at these first two equations, x and z are both expressed in terms of y. So I'm thinking they're just kind of begging us to substitute the 2y plus 1 for x over here, and also at the same time substitute the y minus 2 for z over in this big equation with three things in it. Because if I do that, then I'm going to be having only one variable left over when all is said and done. So we're going to have 20 times 2y plus 1. 35y is still a thing. We haven't replaced y with anything. And then we'll have 50 times parentheses y minus 2. And that all still equals 420. So again, what we've done here, it was pretty intimidating, but at this point we only have y to solve for. Once we find y, we can use that to actually figure out both of these other variables. So let's go ahead and distribute and clean up this left side of the equation. We have 20 times 2y, that's 40y. 20 times 1 is 20. 35y, still there. 50 times y is 50y, and 50 times negative 2, that's negative 100, and again, still have the 420. All right, combining like terms. On the left side, we have 40, 35, and 50y. That adds up to a total of, I believe, 125y. We also have 20 plus negative 100, which is negative 80, and again, still have 420. Adding 80 to the other side, we've got just 500 over there. And now if I divide both sides by 125, that's going to be, let's see here, I think 4. Yeah, 4 times 100 is 400. 4 times 25 is 100. That adds up to 500. Boom. So that's 4 of the 35-cent Valentines. Let's go ahead and plug that back into the x and the z equations that we wrote earlier. So let me use the x equation first. 2 times 4 plus 1 to find the x value. So that's 8 plus 1, which is 9. So that's 9 of the 20 cent. And now we'll plug 4 into the z equation. So z equals 4 minus 2, which is even easier to solve. So that ends up being 2 for the number of 50 cents ones. So he was kind of cheap. He didn't buy as many of the more expensive ones. So altogether then, we had 9, 4, and 2. So 9, 4, and 2, there's a box right here. This EW box has all of those. So there we are. We've crossed off everything we needed to cross off, and all that remains now is to see what's left over and see what it spells out. Okay, time to solve this riddle. The original riddle again was, how did the doe win the big animal race? So looking up here, we didn't cross out the SH, and that obviously is not a word by itself, but we have an E, a P, an A, an S. I'm thinking that she, S-H-E, is our first word, and then P is the start of our next word. So we have P-A-S, and then we have S-E, passe. No, I think we can keep going. We have a D here, so maybe past would be the next word. I mean, this is a race, so the doe has to pass somebody to win, right? And then T is the start of our next word. We have a T-H-E. I'm pretty confident that that's the. And then our last word, we have a B-U and a C-K. Well, that spells out buck. So how did the doe win the big animal race? She passed the buck, right? I get it. All right. Here we go.